Welcome back, students. In this video, we are going to show Minkowski inequality for LP space. Alright. We will use this inequality for triangle inequality property in non-linear space for LP space. What is the Minkowski property? This says that if you have two measurable functions belonging to LP space means that are measurable functions, then their sum is also belonging to LP space, and one is greater than equal to 1 and less than infinity. That means whenever you pick your P, that becomes finite. P can never be infinite. Okay, then this inequality holds. And what is the meaning of this inequality? See, this means this in integration form. All right, in norm form this, and in integration form this. Now let's proceed for proof. First of all, we will show this inequality when P equals to 1. All right, P equals to 1. So this is F plus G norm. All right, this is equals to here, that is this means this is equals to this. So integration over F plus G. Here P is 1, so I can remove these brackets. This is less than equal to what? This is equals to this. And what is this? I can write this as norm of F over 1 plus norm of G over 1. So we have done for P equals to 1. Now suppose P is greater than 1. For this case, consider F plus G raised to the power P. Consider this one. Now this is equals to F plus G into F plus G raised to the power P minus 1. What I did, I just separate one power from this. मैंने क्या किया, मैंने एक पावर को कम करके इन दोनों को ऐसे लिख दिया in product form. And now what I will do is, this is less than equal to mod of F plus mod of G, है ना, into F plus G raised to the power P minus 1. This is equals to, multiply these. What you will get? Mod of F into F plus G raised to the power P minus 1 plus mod of G into F plus G raised to the power P minus 1. This is your 1. As we know, here also a relation between P and Q is 1 by P plus 1 by Q equals to 1. Okay, this is relation between P and Q. This implies 1 by Q equals to 1 minus 1 by P equals to P minus 1 by P. Right? What does this imply? This implies Q equals to P by P minus 1. This is your Q here. Alright, this is your Q. Then from here you can calculate P, and that P is, what is P from here? P is P minus 1 into Q. P is P minus 1 into Q. Now, F plus G. See, what is the purpose for doing this? The purpose is that I want that this function F plus G raised to the power P minus 1 should belong to LQ space, so that I can use Holder's inequality here. Alright, that is the only purpose for this. So P minus 1 into Q equals to, see, P minus 1 into Q is equals to P, so F plus G raised to the power P. Now integrating on both sides, what we will get? We will get this is finite because this belongs to LP space. Now by definition of LP space, what we have, this integration should be finite. By definition of LP space, see, definition is always if and only if statement. You can use that in any way. Alright, so from here what can we say? This is finite. If right hand side is finite and it is equals to left hand side, what does this mean? This means this term is also finite. Is also finite. This imply integration f plus g raised to the power p minus 1 into q is less than infinity. What does this imply? This implies that this, see here power is q, so erase this and this will be belongs to LQ space. Alright, this will belong to LQ space. This is what we needed. Now from 1, what we have? F plus g raised to the power p is, now integrate first part. Integrating 1, what we have? We have this is less than equals to what? Integrate first part. Integration over mod g into f plus g raised to the power p minus 1. Now recall what is Holder's inequality. Holder's inequality says that if this function belongs to LQ space and this belongs to LQ space, then what we have? I can write this as norm over LP space, so here is p, and I can write this as f plus g raised to the power p minus 1 over space q. है ना? Same way here function g also belongs to LP space. So what we have? Norm of g over p into f plus g raised to the power p minus 1 into q. Because of this reason, we firstly shows that this belongs to LQ space. Now, take out this term common from these two. So, I am erasing this term from here. Plus over P space, bracket over this, and in product form, this term is here. Now, if this is equals to 0, this term is equals to 0. If look, if you have something, say a, if a raised to the power 3 is equals to 0, then a raised to the power 4 is also 0. How? See, I can write a raised to the power 4 as a into a raised to the power 3. What is the value of a raised to the power 3? A into 0 equals to 0. So here, if this term is equals to 0, then this is also 0. That means what we have, inequality is already proved. Inequality is obvious. Now we are taking that this term is non-zero. I can write this in integration form as, इसकी वैल्यू इन इंटीग्रेशन फॉर्म क्या होगी? इंटीग्रेशन f प्लस जी रेज टू द पावर p माइनस 1 into q, because this is belonging to what? In our L Q space. That's why I can write this as, now I am erasing from here. Dividing p raised to the power 1 by q. Alright, I am dividing this by this. What I will get? Plus g raised to the power p divided by this. F plus g raised to the power p whole power 1 by q. Alright. into p minus 1 into q raised to the power 1 by q and divide by f plus g raised to the power p whole raised to the power 1 by q. Now, after dividing this, we will get this equation. Now, from here, what can we do? See, this is equals to p minus 1 into q equals to p. So, here both numerator and denominator are same. That's why I can cancel these. Now, here is, this term is equals to this term. Just take power here 1. Alright, if you take here power as 1, then base are same. What you do, if a raised to the power m divide by a raised to the power n, I can write this as a m minus n. I can write in this form. So, in the same way, what I will do here, I will subtract this power from here. Okay. Now, what we get? See, and you also know the relation between p and q is this. So, 1 minus 1 by q equals to 1 by p here. So, I can write this as f plus g raised to the power p is पूरे की power, I can write 1 by p is less than equal to norm of f over p plus norm of g over q. है ना? Now, what is this? This is norm of f plus g over which space? P space is less than equal to norm of f over p plus norm of g over q. Alright, so this is your required inequality. In Minkowski inequalities, the representations are little difficult.